Why should you care? In this review you will find answers to our world's most ambitious questions. Remember to look up at the stars and not down at your feet. Try to make sense of what you see, and wonder about what makes the universe exist. Be curious. Stephen Hawking. It's not often that we pause our busy lives to ponder the profound mysteries of existence. Questions like, where did we come from? How did we get here? Why is the universe made this way? Such queries often remain in the realm of deep contemplation, far removed from our everyday concerns. Fortunately, brilliant minds like Professor Stephen Hawking have devoted their lives to exploring these very questions, distilling complex ideas into comprehensible insights for all of us. Stephen Hawking, renowned theoretical physicist and cosmologist, spent his career unlocking the secrets of the universe. His contributions to science, especially in the realms of black holes and the Big Bang, have fundamentally altered our understanding of the cosmos. In his final book, Hawking goes beyond scientific theories, intertwining the fabric of the universe with the trajectory of humanity, offering a roadmap not just of our origins but our potential future. In brief answers to the big questions, Hawking doesn't just delve into the intricacies of the universe. He relates these cosmic phenomena to human experiences and societal issues, making the complex nature of astrophysics accessible and relevant. For instance, he draws an analogy between a black hole and Niagara Falls, providing an image that helps demystify the abstract concept of an event horizon. Through such metaphors, Hawking makes the esoteric world of astrophysics engaging and understandable. Moreover, Hawking's exploration isn't confined to the distant past or remote corners of the universe. He also ponders the future of space exploration and the survival of humanity. One intriguing question he tackles is where liquid water might exist within our solar system, a critical element in the search for extraterrestrial life. Hawking's insights point to places like Europa, one of Jupiter's moons, as promising candidates, expanding our understanding and curiosity about life beyond Earth. Hawking also discusses an ambitious project that could revolutionize space exploration, Breakthrough Starshot. This initiative aims to develop tiny, light-powered spacecraft capable of reaching our nearest star system, Alpha Centauri, within a human lifetime. Such groundbreaking endeavors underscore Hawking's belief in the boundless potential of human ingenuity and the importance of looking beyond our planet to secure our species' future. Ultimately, Brief Answers to the Big Questions isn't just a scientific treatise, it's a call to action. Hawking urges us to embrace our curiosity and look beyond the immediate horizon, contemplating the larger picture of our existence and the universe. His work encourages a blend of wonder and practicality, prompting us to question, explore, and strive for a future where humanity's potential is fully realized. If you found these insights captivating, share them with your friends, family, and colleagues. Join our community of curious minds by liking, sharing, and subscribing to our channel. Let's spread the wisdom of Stephen Hawking and inspire more people to look up at the stars, ponder the mysteries of the universe, and work towards a brighter future for all. Forces govern our universe, but a divine creator probably isn't among them. Why are we here? Where did we come from? Why are things this way? These questions have been at the heart of human inquiry for millennia. Both science and religion offer answers, but their conclusions diverge significantly. Religion often asserts that human life has inherent meaning bestowed by a divine creator, while science views our existence as a consequence of natural laws and random events. These differing perspectives have fueled a long-standing debate between faith and reason. Humans have an innate desire to understand and explain the world around us. Early explanations were deeply rooted in religious beliefs. Ancient cultures attributed natural phenomena like lightning, storms, and eclipses to the actions of gods. However, as scientific understanding has advanced, we have developed a more rational, consistent, and verifiable explanation. The universe operates like a vast machine governed by unbreakable natural laws. Consider a simple game of tennis. The ball's trajectory is determined by the laws of gravity and motion, without anomalies or exceptions. Variables such as the player's strength or wind speed are just data points processed by these natural laws to predict the ball's path accurately. This example illustrates how natural laws are not only unchanging but also universal. These universal laws apply to everything, from a tennis ball to the largest celestial bodies. The Earth's rotation and an icy meteor hurtling through space both obey these same principles. Importantly, natural laws cannot be broken, even a deity would be subject to them, challenging the theological concept of divine omnipotence. Yet, some thinkers, like Einstein, have proposed a way to reconcile modern science with the concept of God. Einstein referred to God as a metaphor for the fundamental laws of nature, rather than a conscious creator. This view frames God as the embodiment of the unbreakable rules governing the cosmos, rather than a sentient being with whom humans can interact. This interpretation may not satisfy those who view God as a personal, human-like entity. The vastness and complexity of the universe dwarf human existence, making the notion of a divine creator seem improbable. If our traditional explanations for the universe's creation are flawed, we must look to scientific theories to understand how the universe began. We can't logically ask the question, what came before the Big Bang? Most of us are familiar with the Big Bang theory, the leading scientific explanation for the origin of our universe. In a fraction of a second, the universe expanded from an infinitely dense point, smaller than a proton, into a rapidly expanding cosmos that continues to grow today. This groundbreaking theory was significantly advanced by the work of Edwin Hubble, who, in 1929, analyzed light from distant galaxies and discovered that they were moving away from each other. This observation, known as the redshift, indicated that the universe was expanding, suggesting that galaxies were once clustered together in a singularity. Hubble's findings were revolutionary, showing that the further galaxies are from Earth, the faster they are moving away. This observation led to the conclusion that about 10 to 15 billion years ago, all galaxies were incredibly close together, possibly occupying the same point in space. This concept of a singularity provided a foundation for the Big Bang theory. Additional support for this theory came in 1965 with the discovery of the cosmic microwave background radiation, which is considered the leftover thermal radiation from the Big Bang. However, the question of what came before the Big Bang is a profound and challenging one. To address this, we turn to Einstein's groundbreaking discovery that space and time are not separate entities but are interwoven into a fabric known as spacetime. Massive objects with high levels of gravity can warp this fabric, similar to how a bowling ball deforms a mattress. In extreme cases, such as with black holes, this warping can be so intense that time itself comes to a halt. To understand the universe's beginning, imagine the cosmos contracting back into an infinitely small and dense singularity. In this state, both space and time cease to function as we understand them. The classical concept of time breaks down under such extreme conditions, leading to a surprising conclusion: the Big Bang could not have a cause because time did not exist before it. Without time, the notion of before becomes meaningless, rendering the question of what came before the Big Bang logically invalid. This revelation challenges our traditional understanding of causality and underscores the unique nature of the universe's inception. The idea that time itself began with the Big Bang invites us to rethink the nature of existence and causality. As we let this sink in, we are reminded of the vast and mysterious nature of the cosmos, prompting us to continue exploring its many enigmas, including the possibility of alien life. In his final book, Stephen Hawking masterfully navigates these profound questions, blending scientific rigor with accessible language. His ability to tackle the universe's biggest mysteries and hypothesize about humanity's future remains an inspiration. As we delve into his insights, let us remember Hawking's words: "Look up at the stars and not down at your feet. Try to make sense of what you see, and wonder about what makes the universe exist. Be curious." If you found this exploration of the universe's origins fascinating, please like, share, and subscribe to our channel. By doing so, you help us reach a larger audience and inspire more minds to ponder the mysteries of our existence. The enigma of alien life: are we alone in the universe? Aliens have fascinated humanity for decades, appearing in countless movies, books, and video games. But beyond the realm of fiction and speculation, the question remains: what are the chances that intelligent life exists beyond Earth? If we consider Earth as our only reference, the probability of extraterrestrial life seems plausible. Life on Earth began relatively quickly after the planet became habitable, with fossil evidence dating back 3.5 billion years. Given that the universe is about 13.8 billion years old, other civilizations could have had ample time to develop, master space travel, and even colonize their galaxies. The potential for habitable planets further supports the possibility of alien life. Approximately 20% of stars are thought to have Earth-like planets in the Goldilocks zone, where conditions are just right for life. With roughly 200 billion stars in the Milky Way alone, this translates to about 40 billion potentially habitable planets in our galaxy. However, despite these promising numbers, we have yet to encounter any extraterrestrial visitors. One explanation for this absence is that while life might be common, intelligent life could be exceedingly rare. On Earth, it took 2.5 billion years for life to evolve from single-celled to multi-celled organisms, a prerequisite for intelligent life. This lengthy process, combined with the finite lifespan of stars, means many habitable planets might not sustain intelligent life long enough before their stars expire. Moreover, life faces numerous existential threats. For example, 66 million years ago, an asteroid impact wiped out the dinosaurs, Earth's dominant species at the time. Such events are relatively frequent on a cosmic scale, with significant impacts occurring roughly every 20 million years. Humanity's development might be a stroke of luck, as our planet is overdue for another major collision, which could potentially obliterate advanced life. Given these factors, the absence of contact with extraterrestrial civilizations might be attributed to the rarity of intelligent life and the numerous hazards that could extinguish it. As we continue to explore the universe and search for signs of life, we must also consider the precariousness of our existence and the unique conditions that have allowed humanity to thrive. In the words of Carl Sagan, the universe is a pretty big place. If it's just us, it seems like an awful waste of space. Reflecting on this, we invite you to join our quest for knowledge and exploration. Like, share, and subscribe to our channel to help us reach a larger audience and inspire more minds to ponder the mysteries of our existence. Is predicting the future possible? A dive into classical and quantum mechanics. Imagine if you could predict the future, winning the lottery, acing your exams, or even avoiding accidents. This tantalizing prospect raises the question, is it truly possible? Conventionally, the answer is no. However, there is a theoretical scenario, albeit improbable, where future prediction might be feasible. French scientist Pierre-Simon Laplace proposed that if we knew the exact positions and velocities of all particles in the universe, we could calculate their future behavior. This idea, rooted in classical mechanics, suggests that the universe operates like a giant clockwork where knowing the present allows us to predict the future. For instance, if you know your car's position and speed, you can easily predict where it will be in 30 minutes. However, in the 20th century, German physicist Werner Heisenberg challenged this deterministic view. Heisenberg's uncertainty principle states that due to the quantum nature of particles, we cannot simultaneously know both the position and velocity of a particle with absolute precision. The more accurately we measure one, the less accurately we can measure the other. This principle fundamentally altered our understanding of the universe, suggesting that at a fundamental level, the future is inherently unpredictable. This shift in understanding gave rise to the theory of quantum mechanics, a complex and counterintuitive framework that replaced classical mechanics for describing the behavior of particles at the smallest scales. In quantum mechanics, particles do not have definite positions and velocities. Instead, their properties are described by a wave function, which gives the probability of finding a particle at various points in space. This probabilistic nature means that we can only predict where a particle might be, not where it will be with certainty. Quantum mechanics presents its own set of challenges. For one, it allows us to predict only half as much information about a particle compared to classical mechanics. We can determine a particle's wave function but not its exact position and speed simultaneously. Furthermore, quantum mechanics breaks down in extreme conditions, such as inside black holes, where the warping of spacetime complicates the predictions. In conclusion, while the dream of predicting the future remains captivating, the reality is far more complex. Classical mechanics offers a deterministic view, but quantum mechanics reveals the probabilistic nature of the universe, limiting our ability to foresee future events with certainty. As the renowned physicist Richard Feynman once said, "I think I can safely say that nobody understands quantum mechanics." Embrace the mysteries of the universe, and don't forget to like, share, and subscribe to our channel for more mind-bending explorations of science and beyond. The paradox of black holes: escape from the inescapable. Imagine you're on an interstellar journey, only to find your spacecraft drifting dangerously close to a black hole. Despite the looming doom, you might find solace in knowing that you'll witness the mysteries of the event horizon before being crushed into stardust by its immense gravity. Black holes, formed from the collapse of massive stars, are among the universe's most fascinating phenomena. Stars like our Sun maintain their structure through thermal pressure generated by nuclear reactions converting hydrogen to helium. This balance prevents them from collapsing under their own gravity. However, when a star exhausts its nuclear fuel, it collapses inward, forming a black hole where gravity is so intense that not even light can escape, creating what we call the event horizon. The event horizon acts like the edge of Niagara Falls. As you approach, the current intensifies, making escape increasingly difficult until it becomes impossible beyond a certain point. This raises a perplexing question: given the universe's age, shouldn't it be teeming with black holes? Interestingly, Stephen Hawking's groundbreaking discovery in 1974 provided an unexpected answer. Hawking revealed that black holes emit particles over time, a phenomenon explained by quantum mechanics. Space is teeming with particle-antiparticle pairs, which constantly form and annihilate each other. Near the event horizon, these pairs can be separated, leading to one particle being absorbed by the black hole while the other escapes, causing the black hole to lose mass and eventually vanish. This paradoxical escape mechanism, known as Hawking radiation, challenges our understanding of the universe and suggests that black holes are not eternal prisons of matter. They gradually shrink and dissipate, adding another layer of complexity to these enigmatic entities. As we ponder these cosmic mysteries, let's shift our focus to questions closer to home, the future of our species and our place in the universe. The exploration of black holes not only deepens our understanding of the cosmos but also inspires us to reflect on our existence and the boundless potential of human discovery. Feel the wonder and curiosity these topics evoke. Share your thoughts, spread the knowledge, and join our journey by liking, sharing, and subscribing to our channel. Let's explore the universe together, one mystery at a time. As Carl Sagan aptly said, somewhere, something incredible is waiting to be known. To ensure our survival on Earth, we must take immediate and decisive action. While we've pondered the universe's grandest mysteries, it's crucial to address the pressing issues here at home. Our planet faces numerous threats, both beyond our control and within our ability to mitigate. One of the most alarming uncontrollable threats is the overdue asteroid collision, a catastrophic event we currently lack the technology to prevent. This should remind us to concentrate on solvable problems rather than the inevitable. The most urgent of these solvable issues is climate change. Our unsustainable global emissions are driving rising ocean temperatures, releasing more carbon dioxide, and melting polar ice caps. This sets off a dangerous cycle known as the greenhouse effect, potentially rendering Earth uninhabitable, much like the harsh conditions on Venus. To avert this, we need immediate technological and political interventions to significantly reduce our carbon footprint. Equally alarming is the threat of nuclear annihilation. Despite the reduced tension since the Cold War, the global nuclear arsenal still holds the power to obliterate our planet multiple times over. The current geopolitical instability increases the risk of more nations acquiring nuclear weapons and the potential for these weapons falling into the hands of terrorists. These dangers necessitate urgent international cooperation to prevent a catastrophic nuclear conflict. In the face of these existential threats, it is almost certain that without significant action, Earth could face devastation from either environmental collapse or nuclear war within the next millennium. However, this dire prediction also holds a sliver of hope. If we act now, humanity might develop the technology to escape such a fate. The urgency to address these issues cannot be overstated. By focusing on immediate, actionable solutions, we can safeguard our planet for future generations. Let this be a call to action for all of us to engage in efforts to combat climate change, advocate for nuclear disarmament, and work towards sustainable living. Feel inspired by these critical issues? Like, share, and subscribe to our channel to stay informed and join us in making a difference. As Albert Einstein famously said, we cannot solve our problems with the same thinking we used when we created them. Together, let's innovate and act for a better future. We need to start colonizing space to ensure the long-term survival and progress of humanity. When Christopher Columbus set sail in 1492, many dismissed his journey as a waste of resources, yet it transformed the world. Today, the situation is analogous. Despite diminishing space agency budgets due to political and financial constraints, our innate curiosity and drive to explore should propel us forward. Ignoring this instinct is akin to castaways not attempting to escape their deserted island. To reignite our passion for space exploration, we need ambitious, concrete goals. Just as President Kennedy's commitment in 1962 to land a man on the moon by the end of the decade inspired a generation of scientists, setting milestones like establishing a moon base by 2050 and landing humans on Mars by 2070 could capture the public's imagination and revive enthusiasm for space programs. These achievable objectives would pave the way for further exploration. Beyond the moon and Mars, our solar system holds numerous intriguing destinations. Within a century, we could feasibly reach many of our solar system's planets. Europa, one of Jupiter's moons, is particularly fascinating, as it may harbor oceans beneath its icy surface capable of sustaining life. Yet, our exploration is currently limited to our solar system. The vast distances to other star systems pose significant challenges. The nearest, Alpha Centauri, is 4.5 light-years away, making human travel there with current chemical rockets impractical. Advanced propulsion technologies, such as nuclear fusion or matter-antimatter annihilation, are potential solutions but remain centuries away from development. Meanwhile, unmanned spacecraft present a viable alternative for interstellar exploration. Innovative projects like Breakthrough Starshot exemplify our species' ingenuity. This initiative aims to launch 1,000 nanocraft space probes, each equipped with tiny, lightweight sails. These nanocraft would be propelled by powerful lasers from Earth, enabling them to reach distant star systems much faster than traditional spacecraft. While engineering challenges remain, they are surmountable and showcase the potential of human creativity and determination. To conclude, embracing space colonization is not just a lofty dream but a necessary step for humanity's future. As Albert Einstein once said, "The important thing is not to stop questioning. Curiosity has its own reason for existing." Let's channel our collective curiosity and ingenuity towards the stars. We need to be wary of runaway AI. The idea of an artificial intelligence network gaining self-awareness and turning against humanity, popularized by Hollywood in movies like The Terminator, might seem like pure fiction, but it carries a cautionary message. Science fiction often exaggerates scenarios, making the real dangers of superintelligent machines seem far-fetched. However, dismissing these possibilities could be our biggest mistake. Currently, human brains are far more advanced than the most sophisticated computers, which are less complex than the brain of an earthworm. Yet, if AI systems can self-improve, they could trigger an intelligence explosion, surpassing human intelligence and leaving us in a vulnerable position. This is not merely a plot for science fiction, it's a real risk if AI development is not properly managed. While the potential dangers of AI are significant, it's essential to avoid fear-mongering. Properly harnessed, AI could revolutionize every aspect of human life, from eradicating diseases and poverty to bringing unforeseen benefits. The rapid evolution of technology, like the rise of the Internet, shows that predicting the future impact of AI is challenging but full of potential. One of the key indicators of AI's potential growth is Moore's law, which suggests that computers double their speed and capacity every 18 months. If this trend continues, AI could surpass human intelligence within the next century, making the concept of a self-aware AI less speculative and more of a tangible concern. In response to these concerns, awareness and proactive measures are crucial. In 2015, prominent figures like Elon Musk and Stephen Hawking, along with AI experts, signed an open letter highlighting the risks of uncontrolled superintelligence. AI ethics has emerged as a rapidly growing field, emphasizing the need for future safeguards to ensure that AI remains a tool for human benefit. To prevent the potential pitfalls of runaway AI, we must remain vigilant and proactive. As Stephen Hawking once warned, the development of full artificial intelligence could spell the end of the human race. Let's ensure we steer AI development towards enhancing human life and not threatening it. Humanity's journey of exploration and discovery has been a relentless pursuit of answers to the most profound questions about our existence. From ancient civilizations pondering the origins of the cosmos to modern-day scientists unraveling the mysteries of black holes, our quest for understanding has shaped the course of history. With each scientific breakthrough, we have gained insights into the fundamental laws governing the universe, yet these revelations have also revealed new complexities and challenges that demand our attention. As we peer into the depths of space and unravel the intricacies of celestial phenomena like black holes, we confront the awe-inspiring power and vastness of the cosmos. The discovery of these enigmatic entities has challenged our understanding of the universe and pushed the boundaries of human knowledge. However, even as we marvel at the wonders of the cosmos, we must also turn our gaze inward and address the pressing issues facing our planet. While the exploration of space captivates our imagination, we cannot afford to overlook the urgent challenges confronting us here on Earth. From the looming threat of climate change to the risks posed by nuclear proliferation, humanity stands at a critical juncture in its history. These challenges require immediate action and collective effort to mitigate their impact on our planet and future generations. In the midst of technological advancements and the rise of artificial intelligence, we find ourselves at a crossroads, where the promise of innovation is accompanied by profound ethical questions. The exponential growth of AI capabilities raises concerns about the potential for runaway artificial intelligence and its implications for society. As we navigate this uncertain terrain, it is imperative to approach AI with a critical eye, considering not only its benefits but also its risks to humanity. As we contemplate the future of our species and the challenges that lie ahead, we are reminded of the words of Albert Einstein, "The most beautiful thing we can experience is the mysterious. It is the source of all true art and science." Let us embrace the mysteries of the universe with humility and curiosity, recognizing that our journey of exploration is as much about the questions we ask as the answers we uncover. In conclusion, our quest for knowledge is a testament to the human spirit's boundless curiosity and ingenuity. By confronting the mysteries of the cosmos and addressing the pressing issues facing our planet, we have the opportunity to shape a future that reflects our deepest values and aspirations. Together, let us embark on this journey with courage and determination, knowing that our collective efforts can lead to a brighter tomorrow. If you found this discussion thought-provoking, I invite you to like, share, and subscribe to our channel. Together, let us continue to explore the wonders of the universe and work towards a more enlightened and sustainable world.